Good morning, Year 10. At least you found my video. Right, we're going to start a new topic now called logic. I don't need you to do a great deal for this lesson. This lesson will be just an explanation of a simple diagram that you need to learn and reproduce and understand what it does. We will also look at binary. The main part of this lesson, or the work that you will do, is to complete the form on memory that we've done for this term. So here we go. So we're doing computational logic, and to do that we need to understand a little bit about binary. Now I have given another video, or I've put a link on Show My Homework, hopefully, fingers crossed all of this works, which will explain a little bit about base 2, why we use binary. If you're comfortable with the notion that binary is only ones and zeros and don't really want to look at other numbers, then don't bother looking at the video. But if it's sort of confusing and you don't understand the maths behind it, then go and have a look. And if you don't understand, then let me know and I will try and put it in a different way. But computers use binary all the time. That's the only thing that they do. It's all that they understand. And the reason why is because it's electricity. So they're powered either by battery or by plugging into the wall. And either they've got electricity, a presence of it, or there is no presence, it's off. So it's kind of like a switch. And there are billions of switches inside a computer, and all they do is either be on or off. So if there is electricity, if it's present or on, we use a 1. And if the power is off, we use a 0. So they're just the two numbers that we use. And because we use two numbers, and that's all that there is in the alphabet. Oh, by the way, we're going to be doing a magic word in one of the tests. You need to enter this magic word into the test so that I know you have watched the video. So the magic word is gate. So carrying on, we can use this idea to change 1 and 0 by using something called logic gates. And in fact, I will cover this in great detail and show you why they're used and how they're used. But basically they take inputs, two inputs, sometimes one input, and convert them to an output. Now that's probably a little bit difficult to understand, so let's take a look at some logic gates. So there are 3 that you need to know for the exam, but there are far more logic gates in existence. But the 3 that you will need, this is the first one, it's called an AND gate. The shape is very important. It looks like a D in the center. That's the gate. And on the left there you can see that we have 2 inputs and we have 1 output. Now what kind of happens is, depending on what is on the input, whether it's a 1 or a 0 or a current or no current, is going to affect the output. This is the first state, and there will be 4 states for this. So in this picture there is no current, no electricity on any of the inputs, and if there is no electricity on the inputs of an AND gate, then the output is also no electricity. So we say there's a 0 and a 0 for input and a 0 on the output. Sometimes we use true and false, and if we're doing that, then the 2 inputs on the left hand side are both false and the output is false. But we'll look at that a little bit later in something called truth tables. So let's move on and let's see what happens when we put a flicker switch and make one of the inputs live. So here we go. So I've made one of the inputs live, and the important part about this is if one input is live on an AND gate, then no electricity flows through, so the output is always false or 0. So here we'd say that the red line was a 1, the black lines are 0. It's the same if we highlight or put a voltage on the other input. There's no electricity flowing through it at all, so the output stays at 0 and the other input is 0. That's quite important to know, and again we'll see that in the truth tables. The magic part with the AND gate is what happens next. If both of the inputs are switched on, if both are 1, then electricity flows through and the output is electricity, or 1 or true, depending on which way you want to look at this. So that is the AND gate. The AND gate is a D shape and only allows electricity to pass through if both of its inputs are true. The next gate we look at is the OR gate. Now notice the symbol, it's kind of like, I don't know, a Star Trek badge turned on its side, a communicator badge. Again, we're starting off this one with both inputs being false or 0, and the output is also 0. So if we don't put any power on the inputs, then there's no power on the output in an OR gate. If we move on to putting power on one of the inputs, then the OR gate works and there is power on the output. This is different to the AND, where we had to have both of them selected before power would flow through. So this one is saying that one input produces a voltage on the output. And it doesn't matter which one it is, it could be the top one, it could be the bottom one, but as long as one of them is selected, then a current will flow through. And we also get the same if we apply a voltage, 1s on the input, we get a 1 on the output, a voltage on the output. So that's the OR gate. And there's one final gate that we need to learn and understand, and that is the NOT gate. Now, this is an important thing to draw. Notice that it's a triangle. There's a circle on the end of the triangle before the line on the output. That is important. If you don't put the circle on there, it is not a NOT gate, it's something called a buffer. So that circle is required. And here we have the first state where I've got a voltage on the input and there is nothing on the output. And if I go to the next image, there's only 2. If I don't have a voltage on the input, I have a voltage on the output. What the NOT does is whatever we've got on one, it's the opposite on the output. So if the input is true, the output is false. If the input is false, the output is true. These are the 3 gates that you will need to learn. You'll need to learn how to draw them. You'll need to understand how they work, and you'll need to do the truth tables for them, which again we'll come to later. So that's my first shot at logic gates and what they are in the picture of them. I've linked this video on to show my homework and on your lesson. So if we go to the lesson, we've got the OCR video here. I don't know how that's happened. Let's put that back. Got the OCR video here. If you click on this link, it will take you to this video, so you can either watch, look at the presentation and click on the link, or you can go to your lesson and click on the link there, or you can get it from the Show My Homework. This is going to give you a sort of really close look at a silicon chip, not a processor, but what I want you to notice is just how small things are when you go through it. It's going to use the word transistors. We will come to that again later, how they work. But be amazed at how small these things are and what they do. So your learning objectives for this, we just are going to cover the top 2 in this lesson. We're going to explain why data needs to be in binary form. Quickly, that is just because we're using electricity and it can either be on or off, and we use 0 or 1 to represent those states. If you're still unsure about binary, go and have a look at the video explaining binary. And the second objective that I want you to be able to do is to be able to draw or recognize these 3 gates, and or not. So in the next lesson we'll take a look at this. We'll take a look at creating a truth table. For the rest of this lesson, what I want you to do is to answer the questions on the form from the last lesson and about memory. Oh, and I'm going to change the magic word, and I'm going to change the magic word to Womble. W-O-M-B-L-E. If you haven't watched the video all the way through, you will give me the wrong word. So, have a go at the exercises, understand the logic, look it up, research it, do whatever you can. Don't worry too much at the moment about it. It's very critical for the exam. You'll be tested on this quite a lot, and I'll show you how it works in programming as well. So I won't just this is called Boolean algebra. I won't just do the algebra. I will actually show you how it's applied in real programming. So thank you for your time. Don't forget that magic word for me.